So since we have DC circuits and we have AC circuits, DC and AC. We discussed DC, we applied Thevenin's maximum power transfer theorem, and we did several things. And an example of the DC is the batteries. So we have the batteries, and like your cell phone, the batteries like EV, electric vehicles, and the other thing, which is all of those batteries are based on DC. But what's the point of using AC since everything's, not since everything, since the DC is working fine, what's the point of using AC?
It can go farther, or it doesn't, as it goes farther, it doesn't dissipate as much as an AC compared to DC?
Yes, that's one approach. So he mentioned in DC or in AC, we can go for further or longer distances, while in DC, we cannot do this. Or actually in DC, the distance or the power can be transmitted for few or for smaller distance with respect to AC. So if we have DC as, for example, 120 volts, after 1 or 2 miles, the other terminal end will be very low. Will not have, enough energy to even power up a light bulb. So we cannot run the DC for longer distances. Now, also, I would like to mention an overview about something we call it the war between this DC and AC. Between DC and AC. So what happens? This begins in late 1880s. At this time, the standard in the United States was DC. Standard electrical system was DC. Okay. So DC was led by Thomas Edison. Thomas Edison was inventing the DC, and he said, okay, this is what's supposed to be, and that's what we need to have in our electrical system, and that was our standard. Then Nikola Tesla invented the AC, and he said AC has more benefits than DC. Okay, what are the benefits of AC over DC? So basically, we realize some problems that we have in DC. Problems or some limitations in DC. So it will be only for few miles or short distances, few miles, short distance. We cannot transmit this power for example, 100 miles, 200 miles. We cannot transfer that power for that long distances. And we realize that the higher voltage that we have, the longer distances that we can achieve. So we can say that, okay, let's rise the voltage. And when we rise the voltage, we can go for longer distance. Go for longer distance. But at this time, unfortunately, it was hard to step up or step down the voltage. DC voltage. So it was very hard to step up or step down, because if we step up the voltage, and for example, we make the voltage as 100 kilovolts, but at the customer, we need to step it down because your home, for example, 120 volts, you cannot make it as 100 kilovolts. So you need to have step down voltages. At this time, it wasn't easy to step up or step down. And the other thing, which is losses, a lot of losses. And that's also the reason why the DC will not last, or will last only for a few miles, because the losses. So most likely, here is the DC. Then we have a power lines that will go to the load. So in DC, the power lines, as we know, there is an inductor for it. I'm sorry, there is a resistance. So here R, I'm going to call it as PL as power line resistance, and here is RL as load. So our power line, this is depending on the distance or how long the power lines are. So as we know from physics, the resistance of the conductor is rho L over A, right? Rho L over A. Do you remember this for a conductor? Okay. So L is the length. L is the length. So the longer L will cause what? Larger resistance. Larger R. Then larger L, what will happen to the losses? Power losses at power lines equals to I squared times RL. So what's happening? The larger distance, the larger losses. So this also can be a limitation, which is basically in DC, we realize there will be higher losses or very large amount of losses. This makes it sometimes, if you transmit the power for longer distances, let's assume you are transmitting 5 kilowatts, then maybe after maybe 2 miles or 3 miles, you will see the power that for the losses, 4.5 kilowatts, and your load consuming 500 watts. So most likely you are supplying the losses, not supplying the load, which is something that we don't want. That makes a limitation. So at this time, how Edison overcome this problem? Basically, he tried to make every city has its own generator. So there will be a generator, for example, in our city, then most likely the power will be close to the downtown. That's as an example. Like, then closer to the downtown, then you will be, or closer to the generator. So they will make local generation units. Every city or each area has its own generator. That's how we overcome this. But this can be costly. And sometimes we realize like the fossil fuel and the other things that we found these days, we can make some large power plants in a certain area, and we need to deliver it for example, a few states. So we have some power plant that can generate a large amount of power, other than making a local. So which will make it much cheaper other than making local generators. So there was some challenges about DC, which we cannot overcome, or we cannot solve these problems at this time. So again, like making each area has its own generator, this is something unsuitable. Transmitting the power for longer, for few miles, this is also make it infeasible. So what happens, AC was led by Nikola Tesla, tried to find some advantages. So AC says that we can go deliver power for longer distances. That's an advantage of the AC. He say, okay, Nikola Tesla says, there's no need for few miles. We can overcome this problem, then we can deliver power 100 miles, 200 miles, 500 miles, it doesn't matter. That's a big advantage. The other thing is the losses, lower losses, very low losses. And the other thing also, which is we can sip up or sip down the voltage, the AC voltage, easy. How? Using the transformer. So using the transformer, which is sip up or sip down the voltages, then we can sip up or sip down. So the overall idea, we will sip up the voltage for high value, then transmit the power for longer distances. This will make it lower losses. After making it lower losses, then for the load side, we will sip down the voltages, and then you will get it to the customer. So that's how we found it. Then this is most suitable thing. So we can sip up or sip down using the transformer. The transformer, keep in mind, it's not working with DC. It will work only with AC. That's why we cannot do this in DC. And this is something make it a great thing, make it the AC win. So overall approach of AC, here is the source. Then we will step up the voltage. Then it will go for longer distance. Then step down the voltage. Then you will go to the load. Okay? That's overall approach. And here is like, we can call it, this is the power lines. And most likely these power lines can be, as you see in large power towers that you can see maybe out of town. You can see some large power towers, power lines. This is can be considered for high voltages that can be used to transmit the energy up to 200, 300 miles or even 500 miles. Okay? Then AC says that, or Nikola Tesla says, okay, let me do this, and that's something that we can achieve, and we can do it without any problems. So what happens after that? Edison did not stop here. So he said, okay, how can I overcome on Nikola Tesla? Nikola Tesla, make a big advantages about it, but he was not satisfied. So what he did, he spread some misinformation. He was saying that the AC is more dangerous than DC. So he was going so far, even he electrocuted some stray animals and say, look, to prove how the AC is bad, or to prove his point that AC is more dangerous than the DC. So he tried to spread misinformation about AC and some rumors. So because everyone looking for funds for funding his projects. Since he found himself he's losing, then he tried to spread some misinformation. But after that, AC wins. How AC wins? The most likely what happens, the points that makes AC wins, they make call it Chicago World Sphere. That was in 1893. 1893, Chicago World Sphere. So this is also known as, in other words, World's Columbian Exposition. So what happened there? We were looking, or they were looking for supplying power for a specific or for a certain area. So they said, okay, let's make a bid. We want to see how is Nikola Tesla will do, or how is DC cost, overall cost, how is AC overall cost. So Edison said, like, to meet your targets, we can satisfy this by 554,000. That was in 1893. Which is a lot. Then, to supply this, this project or this amount of area by electricity, while Tesla said that we can do this